Hello everyone, this is Simple Math for you. Today we are going to revise some lessons from chapter 7, actually all chapter 7, chapter 10, some lessons, and chapter 11. Chapter 7 is talking about systems of equations and inequalities. Chapter 10 is talking about segments and line segments and some midpoints. And chapter 11 talking about angles, relationships, and two-dimensional, three-dimensional shapes. And let's go. أهلا بكم في Simple Math for you. اليوم سوف نقوم بمراجعة بعض الدروس في الفصل السابع والفصل العاشر والفصل الحادي عشر. الفصل السابع الذي يتحدث عن أنظمة المعادلات والمتباينات. الفصل العاشر يتحدث عن القطع المستقيمة ونقاط المنتصف. والفصل الحادي عشر أو الوحدة الحادية عشرة تتكلم عن العلاقات بين الزوايا والأشكال ثنائية الأبعاد والأشكال ثلاثية الأبعاد. فلنبدأ. Let's start. Question 1. Determine whether each of the following systems of equations is consistent ومتوافق or inconsistent غير متوافق, and if it is independent or independent. State the number of solutions. So we have to determine first if we have solution. If you have a look here, the only one with no solution is this one. No intersections. When the lines are parallel, that means there is no solution. Here we have the same line. The lines are coinciding, so we have infinitely many solutions. And here we have only one solution. And here as well, one solution. Remember, if you have any solution, whether it's one solution or infinite many solution, then the system is consistent. So here is consistent, and here is consistent, while here is inconsistent. لا يتوافقان أصلا. There is no consistency, inconsistent, no solution. Because we have two types of consistent systems, we are going to differentiate between them. If there is infinitely many solutions, then it is consistent and dependent. يعتمدان على بعضهما البعض. And here they are independent because we have only one solution. نقطة التقاء واحدة. So it is consistent and independent. Okay, here from the graph we can easily determine. Here let's see if we have equations. Determine whether the system is consistent, inconsistent, dependent or independent while there is no graph. Of course here we don't need to graph. Let's compare the slopes. If you want to write it in slope-intercept form, then y equals to negative 3x minus 5. And for this one, 3y equals minus 9x minus 15. We divide until we found it in this form. This is the first one. This is the second one. Compare them. If you see, they are, if you look here, I mean, they are exactly the same. Since they are exactly the same, that means they have infinitely many solutions and it is consistent and dependent. Match each system of equation to its correct graph. We have here this question, two equations. Okay, let's compare the slope. The first one, y equals minus x minus 4. The second one, y equals negative 9x minus 12. The slopes are totally different, nothing related to each other. So that means there will be one solution. And the only case here that have one solution is B. Let's compare here. We have the first one, y equals minus x minus 12. The second one is negative 9x plus 6. As you see here, the slopes are exactly the same, while the y-intercepts are different. That means the lines are parallel. When they are parallel, that means there is no solution, and that means it is compatible with C. Of course, the last one will be A, but let's do it. This is already in slope-intercept form. Let's convert that one into slope-intercept form, dividing by 2. This leads to y equals to 9x plus 12. As you see here, the equations are exactly the same. That means we are talking about infinite many solution. We are talking about the same line, and that means the answer is A. Moving to question 4, determine whether the system has no solution, one solution, or infinitely many solution. If it has one solution, name it. Since he is asking to name it, that means we are going to solve it, either by substitution or elimination, whatever you like. So let's look here carefully. We can solve by substitution since we can see here that y is alone, so we can easily transfer the negative x to the other side. So y is x minus 5. Then equation 1 has given to us, sent the value y. Then the other one will receive. What it will receive? So the value will be substituted for y is x minus 5. This one will be substituted in equation 2. So remember, 1 gives, 1 receives. So 3x plus 5, take the y, replace it by minus 5, equals to 15. I prefer to solve by substitution. If you prefer to solve by elimination, go for that. Now 3x plus 5x minus 25 equals 15. Combining like terms, we have 8x equals, take the negative 25 or add 25 to both sides, 15 plus 25, which is 40. Dividing both sides by 8, so x is 5. Since you have the value of x, then we should replace in any equation to find y. If you replace in equation 1, minus x plus y equals minus 5, replace the x by the 5. And then solve it. So minus 5 will go there. So y equals minus 5 plus 5, because this was minus 5, which is 0. And that means we have one solution, which is 5 and 0. This means it is consistent and independent. Question 5. Which expression could be substituted for x in the second equation? Remember, here we don't need to solve. We just need to know what is the expression that we are going to replace. So here we want to replace in the second equation. So we will use equation 1 to solve for x. So x is negative 2y plus 20, or it is the same as 20 minus 2y, this or that. So the expression x equals negative 2y will be replaced in the second equation. So the answer is C. This is the expression that we are going to replace. So we are taking the expression from 1 and replace it in equation 2. 6. Which expression could be substituted for x? This is the same repetition. Okay, by mistake. Which ordered pair satisfies the system? So if you are here willing to check, we will replace in each equation 1 and 2, each order pair until we have satisfaction for both. Yani this is x and this is y. If you replace in equation 1, minus 1 minus the 0 equals to 2. Of course, this is wrong. No need to check equation 2. Go directly to this expression, x and y. Replace in equation 1. So 3 minus 1 equals 2. Correct. Equation 2, so equation 1 correct, so move to equation 2. 3 times y is 1 plus 2 times x is 3 equals to 9. 3 times 1, 3. 2 plus 3, 6. 3 plus 6 is 9. So yes, it is correct. Since both are correct and you have one answer only, then the answer is B. No need to check others. So remember, you need to check both equations. Graph and solve. We need to solve by graphing here. Actually, we have studied many ways to graph. You can choose whatever you like, unless you have a table to be filled. Yeah, for example, here we can solve it in graph it using the slope-intercept form. Remember, we can start this equation 1 by the y-intercept, which is -4, -1, -2, -4. Move according to the rise over run. Our slope in equation 1 is 3, which is 3 over 1. That means I will rise up 3 units until here, and then run to the right until there. And then I will match the first line. For the second line, I will do the same thing. I can do the same thing, of course. I will change the color. For the second line, I'll start by the 3, up 3, it's 3. And then our slope is -1 over 2. That means from that point, I'll move 1 unit down, 2 units to the right until I reach here, and then I will match. It's very clear here that we have one solution here, which is 2, 2, taking 2x and 2y. What if you have to use the table? You are asked to find it, out to find the points using table. Let's change the color here, and you have a table to be filled. For example, equation 1, you have 3x minus 4, y equals 3x minus 4, and you are asked to use, for example, x is 0 and y 1. What will you do? And it's the, there are the best points. Just replace. When x is 0, so 3 times 0, 0, minus 4 is minus 4, so 0 minus 4. When x is 1, 3 times 1 minus 4, 3 minus 4 is minus 1. So the points are 0, minus 4, 1, and minus 1. As you see, the points will lie on the same line that I have graphed before. So this is my first line. There's no difference. All of you will have the same points and the same lines, whatever the points are assumed. If you are to continue with the table with the second equation, which is y equals minus half x plus 3, okay, prefer to use x is 0. And we are not going to use odd numbers since the denominator is 2, so I will use 2. Replace. I will replace x once with 0, so negative half times 0, 0 plus 3, 3. And then the second one, negative half times 2 plus 3, so it's minus 1 plus 3, which is 2. So we have 2 points, 0, 3, and 2, 2. And as you see here, if you match, you will have the same purple line that we have graphed before. In both cases, if you use the slope-intercept form to graph or use the table, you will have one solution, which is 2, 2. Okay. Question 8, which of the following systems of equation has infinitely many solutions? Infinitely many solution means both equations represent the same line. So let's take the first one. If you take this negative 2x there, it will be 2x plus 7, which is not the same. If you solve for y for that equation, so A is wrong. 2y is 4x, so I will divide everything by 2. It turns to y is 2x plus 3. The second equation, y is 4x plus 2. As you see, the slopes are different. So that means they are intersecting, and I will have one solution. So if the question was looking for one solution, you choose this one, but it's not. Let's check the third one. Here, y equals 2x plus 4. And if you divide all by 2, you will have y minus 2x is 4. Take it there which leads to the same equation exactly. 1 and 2 represent the same line. That means infinitely many solutions, and I have this option, right? Let's have a look on the fourth option, just to check. If we divide by 6 everywhere to isolate the y, then y is 2 over 6 x minus 1, which is 1 over 3, the simplest form, minus 1. This is equation 1. Equation 2, divide by 12. So y minus 4 over 12, x equals 7 over 12. Y is 4 over 12, x plus 7 over 12. 4 over 12, divide by 4, يعني y equals 1 over 3x plus 7 over 12. If you compare these equations, you will find that both have the same slope but different b, and that means they are parallel, and this means no solution or inconsistent. If you are asked about no solution, you will choose D definitely. I'm revising everything for your information. Solve the below system of equations in questions using any method of your choice. If you are asked to use any method, don't use graphing. Since you don't have a graph paper, use either elimination or substitution. I prefer to use elimination here. When can we eliminate? We can eliminate if you have the same coefficient for x or for y. Actually, there is no equivalent, no equal coefficients or opposites. So what shall we do? شو نعمل? We have a choice here, and the best way to do that, if you are willing to cancel the x, then the simplest way to do that, just to remember, multiply the coefficient of x here and multiplication of the second coefficient there. This will lead to 8x, and remember you are multiplying by everything. 12y equals 44, and the other one will be 8x minus 2y equals to 30. One may tell me it was enough for us to multiply the first equation by 2. Of course, yes, it is okay. Also, somebody else can multiply this equation by 3. This equation by 3, because it will lead to 3y negative. Yes, of course, this also is applicable. There is no unique way to solve this equation by elimination. So let's continue if we have started by this. Since we have here exactly the same at x, then we will subtract equations. All the members of the equations should be subtracted. So this will be 12y minus 2y. So we have 12y plus 2y, which is 14y. We have 44 minus 13, which is 14. Dividing both sides by 14 leads to y equals to 1. Usually, for any system of equation, we need x and y. Don't forget to replace. If you replace, إذا بدك تبدل أو تعوض عشان تطلع الإكس, use the original one please. يعني إحنا حلينا بطريقة الحذف, بحذف الإكس للحصول على y. وممكن تحذف الواي للحصول على x. It can be like that. Yes, I will solve it later if you like it. And if you replace, don't solve with the modified one. Use the original one. For example, equation 1 originally was that. So I will replace the y by 1. So 2x plus 3 equals 11. 2x is 11 minus 3, which is 8. And x is 4 after dividing. That means the solution will be ordered per 4 and y is 1. 4 and 1. Let's go with the other option. If you have here originally, it's another way. Don't solve millions of ways at the same time, but I'm telling you that some approaches are easier than others. I can easily just multiply this by 3, which turns to 12x minus 3y equals 45. The first equation, I will leave it as it is. So what will you notice here? We have noticed that here we have 3y and negative 3y. They can be eliminated by adding them. So we have 14x is equal to 11 plus 45, which is 56. When you divide both sides by 14, so x is 4. Now, of course, it will not be contradicting with the x equals 4. Replace to find y. I will use the first equation. We have 2x plus 3y equals 11. So, أعوض. 8 plus 3y equals 11. And then 3y is 11 minus 8, which is 3. Dividing by 3, so y is 1. Of course, we have the same solution. If you like this way, of course, it's much better. This is solving by elimination. I used elimination approach. Okay. Now, real-life application related to systems of equation. A restaurant sells only 2 kinds of desserts, pie and cake. A piece of pie costs $4. A piece of cake costs $5. So we have here 2 types. Usually for systems of equation or inequalities, we have 2 types. So we will assume that x is number of pies sold and y is number of cakes sold. So based on that, we will write the equation. A piece of pie costs $4. No, each one costs $5. Each x costs $5, and each y costs $5. The restaurant sells 100 desserts, so that the 100 is what? The 100 is the total amount, number of pies plus number of cakes. Remember to understand carefully. Now, the total cost is $4.73. Remember, this is money. The cost is $4.73, so it will be related to money. How many pieces of the pie and cake did they sell? So we are looking for solving for x and y. The first easier equation that we are writing is the total. Total is 100, and the total comes from both cake and pie. So x plus y equals 100, definitely. This is the first equation. The second equation comes from money. Each x costs $4. Each y costs $5. The total cost is $4.73, and this is the second equation. When you write the equation, you can use any method to solve. أنت تكتب الإيكويشن بعدين أنت حر بطريقة الحذف بطريقة التعويض. It's up to you. If you want to solve by elimination, let's say, then it's easy here to see that if you multiply by 4, x can be the same. So equation 1 will turn to, I'll put it under that one, it will be 4x plus 4y equals 400. No matter who is upper, the other one, above the other one, who is upper, who is lower, no problem. Now, as you see here, we have 2 equations with the same coefficient. So I will subtract to eliminate x. 5y minus 4y is 1y. 473 minus 400 is just 73. So we got y. How can we have x? For sure, we are replacing. And equation 1 is easy to be replaced. So x plus y equals 100. Replace the y by 73. So x is 100 minus 73, which is 27. What does that mean? Conclusion. Number of, he is asking about pie and cake. So number of pies, which we assume x, 27. Number of pieces of cake is 73. So this is 27 pies and this is cakes. We applied here real life application of system of equations. Okay. Now, geometry. Leon cuts the length of 9-foot board into 2 sections. So the total length here is 9. That means directly you can say x plus y equals to 9. This is the first equation that I can write. Good. Now, 3 times the length of the longer section is 3 feet more than 3 times the length of the shorter section. As you see here, the longer section is y, the shorter is x. So let's translate back. 3 times the length of the longer section, so it is 3y, is equal to 3 feet more, so 3 plus 3 times the length of the shorter section, and this is equation 2. This is easy to be solved now. Now, let's try to solve it. Of course, you are free to use the way you like. Remember, if you are using elimination, you have to write them in standard form. Yani x then y equals to a number. Let's try to simplify this as much as we can, since all are divisible by 3. So we have y is 1 plus x, which is much nicer here. As you see, this equation is ready to give. Equation 2 is ready to give 1, is ready to be replaced. Y is ready to be replaced by 1 plus x. So directly we can substitute, use substitution in this is much better. Again, you can use elimination and try to find the same answer. So using equation now 1, which is x plus y equals to 9, I will substitute the value of y, which is 1 plus x. And then I will solve. So we have here 2 like terms, x plus x, 2x plus 1 equals to 9. So 2x is 9 minus 1, which is 8. That means x is 4. And to find y, you can replace here. Y is 1 plus 4, which is 5. So directly we can say x is 4 feet and y is 5 feet. Now moving to inequalities, system of inequalities. Which system of inequalities is represented by the graph? As you see here, both lines are dashed, and definitely we will have greater or less than. Without greater or equal, less than or equal are not there. Anyway, none of the options include that. The simplest way to check is to know that the shading here is above the line. So that means this was greater. And the shading here was also above the line. So also it has greater. So that means both equations should be with greater, y greater than. And this is the simplest way to check that this is the final answer. This is the only one that includes both inequalities greater than. Y alone in slope-intercept form, and it is like this. Another way to do that or to check is to choose a test point. How can we use test point? Choose any point and replace in each one. You should have both inequalities correct for this point. For example, if you take this point, let's say, which is 2 and 1, 2, 3, 4, 5, it's 2, 5. Replace x and y in the first and the second, it should give you the correct one. And if not any of them wrong, that means it was the wrong option. But the first way I have checked was the easiest, of course. Match each system of inequalities to the graph of its solution. Okay. Now here, this is 1. X plus y greater than 4. We have 2x minus y less than or equal to 3. I would prefer to write each equation in slope-intercept form. Yani for example, here y more than negative x plus 4. And here, it will be minus y less than or equal negative 2x plus 3. And when you divide by -1, so it is y greater than, reverse the inequality, remember, when you divide by a negative number, so it is 2x minus 3. Now, as you see here, both of them are more than, greater than. So if it is greater than, and one of them is dashed, and one of them is solid, so one dashed, one solid is the only one in B, and as you see here, both are shaded above, so it matches with B. This is the best way to do that. You will do the same thing for the second and the third one, and you will find that C here is the right option, A here is the correct option, because both are dashed anyway. 14. Jason graphed systems of equations, or system of equation, actually inequalities, actually, not equations, wrong. Which region of the graph is the solution of the system? Okay, we have here, as we have discussed now, this is already like in slope-intercept form. One is ready, it's a dashed line, and the shading will be below. So this is the shading, we can say, for the first line, which is the dashed already. Okay. The second one, which is less than or equal, which is the solid line, I will write it in slope-intercept form. So 2y less than or equal x plus 1. If you divide, so y less than or equal half x plus half. So this means this will be shaded below the line, less than or equal. So it is below the line. So we will take this line and shade below. The solid line will be shaded below. Which region includes both shading at the same time? Definitely this region, which is 2. Alhamdulillah. 15. Select all the ordered pairs that are solutions of the below systems of inequality, system of inequality. Actually here, there is no graph showing here. So what shall we do? It's not a good idea to graph because there is no graph paper here. So what shall we do? We have to replace. Let's check here the first one. This is x and this is y. If you check equation 1 in the equation 1 first, 6 less than negative of -5. So it gives us 6 less than 5, which is wrong. So definitely this is wrong. This is x and this is y. No need to check the other one if the first one is wrong. So -3 less than negative of -2. It's giving -3 less than 2. Yes, it's correct. So let's check the other one. 2 times -2 plus the y, which is -3 more than 2. So -4 minus 3 more than 2. Of course, it's wrong. -7 is never more than 2. Moving to C, it'll be wrong. Let's check E. E says that this is x and this is y. So -5 less than negative, and the x is given to be 4. -5 is less than -4, correct. Let's take the other inequality, 2 times 4 plus the y, which is -5, more than 2. So 8 minus 5 more than 2, of course 3 more than 2, yes. So this gives me both correct inequalities. So I choose this, and this will apply also to that one. So if you are asked to select the proper ordered pair, you have to replace in both inequalities, and both of them should give you the correct inequalities. Okay. Fatima makes hats and scarves. The table shows the time and the cost of materials to make each. She wants to spend no more than 60 hours and $20 making hats and scarves. Does Fatima have the time and money to make 12 hats and 4 scarves? Let's check about it. We should know that the time must be less than or equal to 60 hours. This is mentioned here. So time less than or equal 60 hours. Also cost should be less than or equals to $20. These are the constraints, الشروط اللي عندنا. Now, does Fatima have time to make 12 hats and 4 scarves? Okay, let's check. Time to make of the hats are 3. This is 3 times 12 hats plus 4, because the one hat needs 3 hours. So we have 12 hats, 3 times 12 plus 4 times 4 scarves will be 36 plus 16, which is how much? 52. So this is less than or equal to 60 hours. Good. Let's check the money. The money, we have cost to make 1 hat is 1. We have 12 hats. And the cost to make 1 scarf is 4. So we have here 4 scarves. Total is 12 plus 16, which is 28. So the total cost $28, which is exceeding the $20 that she has put as a condition. Since it does not satisfy both at the same time, so that means Fatima can? No, she can't. So we have to find out both conditions correct. The hours and the time. For the hours, it's okay, but for the time, it was not okay for her. Solve by graphing the below system of inequalities. Okay. To solve system of inequalities, we will follow the same procedure as graphing the lines, but we will add first, if it is dashed or solid. Second, we will add shading. So let's start by the first inequality. As we have done with the lines, the graphing lines, we will start by the y-intercept, which is in our case 2. Then we will move according to the slope. The slope is rise over run. So I rise up 1, 2, 3, 4, 5. Running 2, so 1, 2, I will reach here. So this will be my first line. Before I match, I need to check whether it's solid or dashed. Since it is greater than or equal, that means the line is solid, متصل. And I will match my line here. Now, then I need to shade. Since it is y greater than, and y is positive here, greater than, that means y, my shading will be above. And let's here take the same color to shade the region above that line. Finish the line and then move to the second line. Let's choose another color, and it's recommended to choose another color for inequality 2, starting with -2, moving according to the slope. Our rise is 1, run is 2, so move up 1, run 2 to the right, and match as well. And it is also solid line because it is greater than or equal. Yes, it's also greater than equal. And as you see here, when you shade, you will shade also above the line. So our shading will interfere with the other one. What is the region that includes both shading at the same time? Actually, let's shade it, everything. This part, as you see, this part includes both shading at the same time. So this is my solution. Yes. Make it as nice as possible. So this is the shaded part. Some other approaches are taking test points. So how can we use the test point? If you want to use the test point, use test point anywhere. For example, if you take test point here, 0, 0. If you take it 0, 0, you will know that this is not, of course, you test point for every line. If you see that 0, 0 here, for example, the first line, replace y by 0, x by 0, it will lead to 0 more than or equal to 2. This is wrong. That means that the shading will not include this test point, and you will shade not below, above. And that's why our shading was correct. I will not shade the region including this. Okay, question 18. In order to prepare for your barbecue, you go to the supermarket to buy hamburgers and chicken. Hamburgers cost $2, so this is the money now, per pound, and chickens cost $3 per pound. You have no more than no more than means less than or equal to $30 to spend. You expect to buy at least, so the quantity should be 3 pounds hamburger. So I will call the hamburger X, and I will call the chicken Y, so that you can talk about X and Y easily. So again, what are the conditions? We have no more than $30 to spend, and you expect to buy at least 3 pounds of hamburgers. So this one, at least, على الأقل, more than or equal to 3 pieces. So X, أول واحدة سهلة, X more than or equal to 3. Easy. He's not putting any condition for Y, just at least 3 pounds of hamburger. Write the system of linear inequalities. So we are ready with the first one. He's saying not to solve, which is better. Now, going to money, we will add money with money. Since each X, each hamburger costs $2, so 2X will be the total cost of hamburgers. Since each Y, chicken costs $3, so كل chicken 3Y. Adding the cost will lead to 30, but we need less than or equal to $30. So this is easy. Now, system of inequalities. Okay. Now we will move to segments. What is the length of AZ? Use the following information. A is between Y and Z. So we have here a segment Y, Z. A is between, somewhere between. We don't know where it is. I will put it here. YA from here to here, sketch better to know, it's 22. YZ from here to there is 166. So if you graph properly, you easily can know what is AZ, what is the length of AZ. So we are looking for this one. So أكيد it is 166 minus 22, which is 144. Okay, let's see here. Question 20. Find X if B is between A and C, and it's given here the dimension. AB is X plus 5, BC is 2X minus 3, and this means AB is congruent, equal in measure to BC. AB is congruent. You can also have these ticks to show that they are congruent or equal in measure. Simply, since AB is equal in measure to BC, we will replace AB equals to BC. And we will solve the equation easily. So X plus 5 equals 2. 2x minus 6. So this will be x minus 2x is equal minus 6 minus 5. And this is minus x, because 1 equals minus 11, dividing by minus 1 both sides, so x is 11. He is asking about x only, that's it. Question 21, find the value of x and fg if between E and G, EF is 7, given. Here, this is given. And FG is this one. He didn't mention that these are congruent, so we cannot assume. EG totally is 3x minus 4. So how can we start? Since the total is 3x minus 4, that means EF, F is between them, plus the FG equal to from E to G. أكيد يعني هذا زائد هذا يساوي التوتال. So we will replace. EF is 7 plus FG is 2x minus 5 equals total EG, which is this one. And then you just need to solve it. 7 plus. Of course, you cannot add 7 plus 2. Remember, multiplication comes first. 2x minus 10 equals 3x minus 12. 2x, 7 minus 10 is minus 3. And combine like terms. Negative x is minus 9, so x is 9. After finding x, he is asking about fg, and it's given to be 2x minus 5. So since x is 9, I will replace 9 minus 5 here, so 2 times 4, which is 8. So this is it. These are the answers. X is 9, FG is 8. 4 students are standing in a straight line in this order. So we have here straight line. They are standing in order. Fatin, Maryam, I don't know the distance, Maisa, and Ruba. The distance from Fatin to Maryam is 4 times the distance from Maryam to Maisa. Since I don't know the distance from Maryam to Maisa, from here to here, I will assume that this is x. And since this is x, then the distance from Fatin to Maryam, he said 4 times, that means this will be 4x. Tamam. You have to assume one of them because we don't know them. Next, what will you do? Let's continue with the story. The distance from Fatin to Ruba is 3 times Fatin to Ruba, يعني from here to there, من الأول للآخر, is what? 3 times what? The distance from Fatin to Maryam. From Fatin to Maryam, 3 times what? Fatin to Maryam, which is 4x. احنا قلنا يعني هذه 4x. So here we put all the dimensions needed. And the distance from Maisa to Ruba, يعني كل المسافة من الأول للآخر 14 whole tiles, 14. So how can we solve this puzzle? Actually, the sum of these parts will be equal to 14. These parts are 4x, which is from Fatin to Maryam, plus x, which is from Maryam to Maisa, plus what also? We have here another one, plus so 4x plus x أيوة equals 14. صح؟ 4x, so total 3 by 4x I mean is equal to 14. Again, the distance from Fatin to Maryam is 4 times the distance, okay. And the distance from Fatin to Ruba, we said Fatin to Ruba is 3 times that, the Fatin to Maryam. The distance from Maysa to Ruba, okay, Maysa to Ruba, not this one. غلط هاي في Maysa to Ruba, not Fatin to Ruba. This one only is 14. Yes, from Maysa to Ruba, so I did a mistake here. Maysa to Ruba is 14. Yes, so that means 4x plus x plus 14 is equal to the total distance, which is that one. يعني خلينا نلخص مرة ثانية. Let's take another color. So that means this distance plus this distance plus this distance totally equals to the total distance, which is that from Fatin to Ruba, which is 3 times 4x. And this means I need to solve 4x plus 1x is 5x. 3 times 4x, 12x. So we can take this here, 7x equals 14. And that means x is 2. Since x is 2, he is asking us about the distance from Fatin to Ruba. From Fatin to Ruba, we have 12x, which is this one. هذا يعني 12x طبعا. So this means Fatin to Ruba is 12 times the x, which is 2, which is 24 tiles. This is the answer. Okay. Let's stop here and then we will continue